In today's video, I really want to focus on the idea that when you analyze your flow or mass cytometry data, or any single cell data to be honest, you should really focus on your feature generation. And I would argue that this is the most important step, that is taking the single cell data and converting it into meaningful features, and a common example is cell subsets or clusters. Quick reminder, I was talking about analysis pipelines and how you want to take your raw data and convert it into meaningful biological insights. And the pipeline is the series of steps that connect these two. And I was talking about how this is a multiple choice questionnaire where for every step along the way, you pick the algorithms or the methods that you want to use. And throughout these videos, I was focusing on these two steps of cleaning and feature generation. I barely touched on statistical analysis and on visualization. And the reason is, I would argue that these two steps are the most important. In fact, they are critical. And if you get them right, everything else is going to flow from that, while if you mess them up, then you can expect nothing but trouble. And there's two papers that touch on this. The first one is Soneson and Robinson. This one is from Nature Methods 2018. Full disclosure, this is talking about single cell RNA sequencing, not about flow or mass cytometry. And the money shot from this paper is this figure 5, where you can see the different methods for differential analysis, differential expression that the authors surveyed, and they are rated across different metrics, while generally speaking, the list is ordered by the quality of the method. And just zooming into the top of the figure, you will notice that there's all these fancy stuff like HR and MAST and Lima. And then number 6 on the list is a t-test. And in many ways, this rank is comparable to the top 6. So you could use all of these fancy methods, but more often than not, a t-test might be everything you need, a very simple and straightforward test that you can run even using Excel. And here's another relevant paper. This one is Vieth et al. That was recently published in Nature Communications. Once again, single-cell RNA sequencing. And what Vieth et al. Has done, they tested all possible combinations for their single-cell RNA-seq pipeline. Once again, not flow cytometry, but a sister field. So they tested a total of 3,000 different pipelines, and their conclusion is that the largest impact on performance came from the normalization methods. In other words, the equivalent of cleaning and feature generation. And a good normalization prior to differential expression testing alleviates the need for more complex methods. And anecdotally, going back to Michelmeyer et al., the paper I surveyed in the previous video, where they had 42 chikungunya patients and 2 different time points, and they used mass cytometry to measure a panel of 30-something markers. For that paper as well, the money shot is essentially a t-test, followed by multiple testing correction. So, just to summarize, when you're doing these kinds of studies, the most important thing is the biology. And the way that you indicate the biology to your statistical test is through the feature generation. So make sure that your cleaning is on point, make sure that your clusters make sense, or that your traditional gating follows your expectations of the data. And once you have that, that is probably the most important processing you can do for your data set. So with this, I will conclude this 4-video series for analysis pipelines in flow and mass cytometry data. Thank you for listening and for sticking it to the end. And I encourage you to subscribe to our YouTube channel and also to our LinkedIn. I'm posting this kind of content on a regular basis, survey of scientific papers and methods, and LinkedIn is the best way to find this. Thank you for your time and have a wonderful day.